Hello everyone, welcome back to another video on this channel, or welcome to this channel if it's your first time here. This is the first video in our unit on machine learning, and the purpose of this video is just to give kind of a brief introduction to machine learning, kind of what is it, what are some distinctions within machine learning, that kind of thing. So kind of motivating the start of this video, I have the following question, and it's what do you think machine learning is, and what have you heard about it? So when we did this in lecture together, I polled the chat and asked for some ideas. So there's no live audience here when I'm recording this video. So instead, before I started recording, I asked ChatGPT for some insights, and I picked out some of the ones that came up during our live lecture earlier this week, and also some that I've just seen and heard about. So kind of common thing that we hear is machine learning is magical / it's the future. There's lots of excitement about it in the media. And for a lot of people, it really does seem mysterious. Kind of what is it? What's it all about? So kind of counter to this, it's magical idea. Well, kind of in some sense, all it is training algorithms to learn from data. And you might ask, well, okay, what does that mean? And that's a little bit of what we'll get into in this class, especially in this unit on machine learning. But at least it's a little bit less mysterious, something that we can kind of attach more concrete ideas to. In terms of just the hype around it in the media, this is wonderful, but it also can lead to some unrealistic expectations. So certainly plenty of limitations. ChatGPT brought up a good point of privacy and ethical concerns. So how is data collected and used, especially data about people and like their health information, for instance? And also our models are susceptible to bias, right? So bias can be inherited from the training data that we pass it. And if we're not there to kind of search for this and are aware of it, it can actually amplify certain biases. So just some kind of big overarching ideas, positives and negatives. Again, I got these by just kind of chatting with ChatGPT, but it was pretty similar to what was discussed during the live lecture. So for our class, again, we don't have a set textbook, but an introduction to statistical learning, the Python version, so with applications in Python, just was released this year in July, so very recently. And this is part of a famous textbook series. The most famous version, or kind of the one that I'm most familiar with, is the one that has applications in R, the programming language. So very exciting now that we have the Python version. This is available as a free download, so free PDF available online. And I'll be pulling some examples from this textbook, as well as a different one that I'll bring up in just a little bit. So before we kind of get into some details, I want to talk about something called labeled versus unlabeled data. And I really love these pictures. I'm going to be using them a lot throughout this video. And these come from El Serrano's Grokking Machine Learning textbook. I was able to find it online for free, or at least see a preview of some of it. And that's where I got these pictures from. So in just a bit, we're going to be talking about something called labeled data. And maybe that's a little bit strange if you haven't heard of it. You can imagine that we have data types, or kind of data that's given as these pictures, right? So here our data is pictures of cats and dogs. And so for instance, without any of this information underneath, all the way here on the right, this unlabeled data, all we have are these images. So kind of just looking at these top two, I can say, well, that's a dog, and here we have them labeled dog. And the bottom two, I can say, well, those look like cats, so I can say cat. But the idea is that effort had to be made here, right? So labeled data, it's very nice. We have these nice labels, descriptions, but the idea here is that humans need to apply labels. So kind of, let me make a note of that here. So humans need to apply labels. And that's kind of one of the difficult things about labeled data is there's this upfront effort and cost, right? Somebody needs to sit down and make these labels, make these decisions. So similarly here, we can have the weight of the dogs, weight of the cats, that's still labeled data. For us, labeled data is going to be basically all that we deal with. But there is unlabeled data, and we'll see where that comes into machine learning. So now let's get into kind of the two main camps of machine learning. This isn't kind of the only two divisions, but these are kind of the biggest two, or the two that we'll be focusing most on in our class. So there's supervised learning and unsupervised learning. And again, my reference is coming from both ISLP and the IBM blog. So just, basic ideas, kind of distinctions, that kind of thing. So main kind of part of supervised learning is the use of labeled data sets. So use of labeled data sets. So again, think back to that picture we had on the previous page. These are things like dog, cat, like these pictures being labeled. And what we do is we then train an algorithm. So train algorithm into predicting or classifying data. And kind of the key here is we can imagine we have some observations, right? So kind of dogs, cats, and for each of them, there's some associated response. So there's some correct value we're trying to predict. So kind of some correct value we want to predict. On the other hand, we have unsupervised learning. So this is going to be not covered in Math 10, so not covered in Math 10. So what that means for us is all of the machine learning that we do in Math 10 will be supervised. So all Math 10 ML. And the key distinction, so we saw that supervised learning used labeled data sets. So as you might guess, unsupervised learning uses unlabeled data sets. So uses unlabeled data sets. That's not to say that the data sets can't have labels. It's the kind of situation where if there are labels, we'll just ignore them. And kind of the idea here is instead of aiming to kind of predict some correct value, so, we have a correct output, we want to be able to predict it. It's more about discovering hidden patterns. So kind of without the need for a human to say, find this pattern. So kind of, I'll say, discover hidden patterns. I think that was the wording that was used in one of my sources. So discover hidden patterns. And that's not to say that human involvement isn't needed at all. So in particular, kind of people are needed to validate the results. And I'll give an example of that after I write it down. So kind of data scientists needed to validate results. So kind of, I think an example that was given in the IBM blog was you can imagine kind of a model that looks at shopping habits and kind of recommends products for the online shopper to buy. So for instance, you can imagine the online shopper is buying, let's say, cat food and a cat tree, and then the algorithm recommends that they buy, let's say, I don't know, like a dog leash or like dog food, something like that. So you'd need a data science to kind of validate, is that a good prediction or is it not? So those are the two main camps. Again, there are more, but these are the two that we're going to kind of consider most often. And again, coming from graphing machine learning, I thought these graphics were really great for kind of showing the distinction. So I think based off of how I'm sharing my screen right now, the text, if I can zoom in on my side, but I can see it's not zooming in my recording. So I'm just going to read the descriptions. So we can kind of imagine our model as these factories. These are kind of these rectangular shapes here. On the supervised learning side of thing, we can imagine we have a data point. So here's a picture of a dog that wasn't contained in our original data set. And the caption says, a supervised learning model predicts the label of a new data point. And the dog says, what am I? And the model says, I think you're a dog. And the second figure says, supervised learning follows the remember, formulate, predict framework. So what happens is we pass it the data. So we have dogs and cats with labels and the word here, remember. and then it formulates, so kind of divides up the data, says how can I distinguish between dogs and cats, and then it makes a prediction. So here it has a dog it's never seen before and predicts, I think you're a dog. On the other hand, so unsupervised learning, here's kind of, again, similar setup, and I'll read the caption. It says, an unsupervised learning model can still extract information from data. For example, it can group similar elements together. And I really like this little speech bubble here. So again, it's kind of grouped the two dogs together, the two cats together, and it says, I have no idea what you gave me, but I can tell you that these two on the left are different from the two in the right. Again, I really like these examples. I think it does a good job of distinguishing between the two. I know at first it can be kind of strange. How are they really different? But again, like I said, supervised learning is going to be where we spend most of our effort. So last part of this video is I want to draw a distinction within supervised learning. So first type of supervised learning that we're going to see in Math 10 is something called regression. And the main situation where we use this is we're trying to compute a continuous/quantitative value. So for instance, if we're doing Altair encoding, you would encode something that follows like this regression as Q. So that's the quantitative encoding. One of the first examples we'll see is of linear regression. So you can imagine, let's say let's think back to the cars or the miles per gallon data set. So let's see here, or maybe the taxis data set. So let's have something like the distance traveled and maybe the time it took. And then let's say I have a whole bunch of data points. And what I do is I say, okay, well, I think this is a line that best fits the data. And now what we can do is we can say, well, given a point that's not contained in my data set, so for instance, if I'm considering whatever this distance is, there's no point that has exactly that distance. I can say, based on this line, I predict this value here. So it would take this amount of time. So here we're predicting this quantitative value. So opposed to regression, we have classification. So if you saw, or kind of if you know that regression deals with like this Q encoding, well then we can think of N or O encoding in Altair. So what we're doing here is we're computing a distinct value. So kind of computing a distinct value. So this again would be something like N or O for ordinal in the Altair encoding. Maybe an example of this is, again, we can have maybe some data points representing different animals. So think back to the dog and cat example. And maybe I say, okay, everything over here is a cat. And everything over here is a dog. And then if I kind of have something that falls outside of it, well, then I need some way of determining where it belongs. And there's lots of different things we could do. We could say, okay, maybe I look to the center of the cluster and say whatever one has the shortest distance, that's where it belongs. But again, classification, this deals with computing a distinct value. So we could think of classifying an animal as a cat or a dog. In regression, we are trying to compute some continuous quantitative value. So again, let's say I want to predict time as a function of distance, so kind of time of a taxi ride. And I kind of say, okay, well, I think it fits along this line. So I think that's all I want to say in this video. Thanks for watching. And in the next one, we'll talk about performing linear regression in Python. So see you there.